5a. Today we are going to continue factoring, but we're going to take it one step further and we're going to solve. So we're going to find solutions to polynomials by factoring. So have your notes out for lesson 4-5, please. All right, we're going to start here. It just says recall from chapter 3, solutions to a polynomial. In chapter 3, from first semester in part 1, you did solve a lot of quadratics, and when you graph them, there's a lot of ways to call your solutions. They can be called roots, x-intercepts, or zeros. So all those all mean solution. So whenever you're looking at a graph, you are looking for those x-intercepts. So it crosses x here at -3, it crosses x at -1, and it crosses x at 4. So these are the three solutions for this polynomial. So it can cross more than 2 times for quadratics, up to 3 for a cubic. Okay, so we will use factoring to solve solutions. The factors of this polynomial are this. So in lesson 4.4, we factor our polynomials. This time we're going to take it one step further. If I put this equal to 0, my answer, my solution, will be -3. So it says the solution is the x value and the y value is always, so we take a look at all these y values. I can see that all the y values are 0. So the solutions must be set equal to 0. So step 1 on all of our polynomials, we want to make sure 0 is on one side, and then we're going to factor to solve. Here we go. I want to start with some basic ones, talking about the zero product property. This one is saying that if you can write as a multiplication, which is factoring, then this is true. So right where the multiplication is, you're going to write these separate and set each part equal to 0. So here's multiplication in the middle. So this first part equals 0. And that group, the second factor, x plus 5, is also equal to 0. From here, you solve them separately. This one on the left is done. X is already equal to 0. This one we're going to solve, so we're going to do -5, -5. So x equals -5. So for this particular example, there are 2 solutions. Okay, take a look at example B here. And this is already factored, so whatever's in front of the multiplication, set it equal to 0. And then inside the parentheses, x minus 2, set equal to 0. We are going to solve both of them. Opposite of times, so that's 5 times x. So we're going to divide both sides by 5. And here we're going to add 2 to both sides. And those are our solutions. Okay, so if I plug this x value into our original equation, it will equal 0 perfectly. That's how I can check my answers as well. All right, let's continue. Go ahead and try these on your own. These are already factored. Go ahead and set each part equal to 0 to solve. Okay, so there are 2 factors here. There's the multiplication. Set them equal to 0 and solve them separately. Add 2. And on the right, subtract 1. Now, on example D, there's a number, they would call this a constant in the front. If that constant doesn't have x, you don't have to worry about it. You can ignore that constant of 3. So we're going to take the factor with the x in it and this last factor with the x in it, and we're going to solve those for the x value. Go ahead and undo. And the 2 solutions are -3 and 1. All right, so those were warming up questions for the idea of the zero product property. Now we're actually going to factor. Oh, excuse my transition there. All right, so in lesson 4.4, we did a lot of factoring ways. Sometimes you just find what they have in common. I see that they're both even, so let's factor out a 2. But they all also both have 1x. So I'm going to factor out a 2x to the front. And then 2x times x squared will give me 2x cubed. And 2x times a -4 will give me -8x. Okay? All right, from there, if you can factor again, you can. So I can see x squared minus 4 can be factored one more time because it is x squared, it is a negative sign, and that 4 is a perfect 2 and negative 2. So the middle term cancels out. So watch out still for those perfect squares. These are difference of squares, so subtractions especially, okay? So this one actually has 3 factors. This right here, times, so that's a factor. Set this first part equals 0. The second group here equal to 0, and the third one equal to 0 as well. And then solve them. Remember, anytime pause the video, try these problems a step ahead and then play the video to check. First one here, divide by 2. Nothing divided by 2 is still nothing. Opposite of plus 2 would be minus 2. And then opposite of minus 2 is plus 2. So here we have 3 solutions. Okay, all right. B is very similar to A. Pause the video, try it out, and then check your answers when you are ready. Here, look for the greatest number that they share. The greatest common factor is 7, and they both at least have an x. So let's pull out that 7x. Think distributive property. So 7x times a positive 5, and 7x times a negative 7 with an extra x. All right, there are 2 factors here. They're the front and inside. So set them each equal to 0 and solve them separately, please. Divide by 7. Nothing divided by 7 will give you 0. Take your time on this one. You still have to subtract 5 first. So I would do minus 5 on both sides. And then I would divide by negative 7. So negative 5 divided by negative 7 will give me a positive 5/7. All right. Go ahead and try C and D before you check your work. C is very similar to A and B, so they had the greatest common factor of 2x, and then distributive property, 2x times 1x, 2x times 4. Break it apart to solve. Go ahead and set each part equal to 0, and you have 2 solutions there. Subtract 4. Now this one, if you look, they do not have anything in common, so be careful. This is a trinomial, so your A is 1, your B is negative 2, and C is negative 15. So you need to draw yourself an X, put negative 15 on top, put the negative 2 on the bottom, and let's brainstorm some numbers. So you want to think, what numbers multiply to give you 15? And because it's a negative, I know they have to be opposite, so I need one positive, one negative, and they cancel away to give me 2. So 3 and 5 are great numbers. Did you put the negative with the 5? We do need these to add up to a negative 2. Okay? All right, they are factored. Let's set each part equal to 0 and solve. Go ahead and undo. So we're going to do plus 5 here, minus 3 there. Okay? We're going to expand and do a lot more factoring. So I'm going to speed up. Remember, anytime you need to pause the video, go ahead and do so. Right, E is slightly different. This does not equal to 0. Did you notice that? So step 1 in here is please go ahead and subtract 48 to both sides. Always step 1. Write yourself a note. Star this problem. Make sure everything equals 0 before you factor. Okay? All right. Just like letter D, you want to factor. Let's brainstorm some numbers for 48. What I notice is that this number is very small. So try to find 2 numbers that multiply to give you 48 that are pretty close together so that when you subtract them, you get just 2. So I wouldn't try 2 times 24. Those are really far apart. Try 6. And 6 and 8 are great numbers. I'm going to keep the negative with the 8 because I want a negative 2 in the middle. Remember, the bigger number should match the symbol in the middle. Okay? Now set each part equal to 0 and solve. Okay? You want to undo, so here, plus 8 and minus 6. All right, now we're going to add those multiple parts. In lesson 4.4, most of the examples always say factor completely, factor completely. So I can see that they're all even. So right away, I'm going to find that greatest common factor of 2, but also they all have at least 1x. So I'm going to put 2x in the front of a big parenthesis for me, please, and then go ahead and multiply back. Now, here's the tricky part on this one. We're not done. This inside can be factored again. So we need to have another trinomial. So again, you want to draw your x, put the 4 on top, the negative 5 on the bottom. You want factors of 4 that will add up to a 5. Did you know 4 times 1? Always try that times 1 because 4 and 1 will give you 5. All right, I do need a negative 5. So let's make sure they're both negative. Okay? Remember, it's okay to put negative 1 first and then negative 4. All right, this one has 3 factors. Notice this has an x, so we can't ignore that. Set 2x equal to 0, the middle one equal to 0, and then the third one equal to 0. And solve them separately. First one, if you divide by 2, nothing divided by 2 is still nothing. Don't forget, that's an answer. The middle one, undo that minus, so we're going to do equals 4. And that last one, we're going to undo that minus by adding 1 as well. All right, we got 3 answers. Yay! All right, this one's a long one. I know. I want to give you a good amount of examples with a lot of factoring, so hang in there, okay? All right. I want you to go ahead and try these. These are almost identical to the one we just did. So please pause the video before you continue and check your answers. All right, did you try it? I hope you did. G has a common x. There are no numbers in common, but a single x. So you pull out a single x first, and then brainstorm some numbers for 21. Notice this is a plus sign, so they both have to add up to 10. Okay, and there's not a lot of choices. 3 times 7 is a great pair. And we want both negative to add up to negative 10. Okay, you should have 3 answers. There's an x in the front, so there should be 3 solutions for this one. All right, last one like this. So we want to factor out. I do see a common number. It is 4. So divide everything by 4. That's how I would do that. I would put 4x in the front and divide them separately by 4 to see what's left inside. All right. Now inside, I need factors of 16 that will add up to 8. I know 2 times 8, but 2 times 8 won't add up to there. So, 4 and 4 will give me 8. So 4 and 4 it is. Now, this one I want to show you. If you solve them, the middle one and the last one are exactly the same. We call it a multiple or double root. So sometimes when you have a double root like this, you actually only see 2. So this one has 2 solutions because negative 4 is considered a double or repeated root. Okay. All right. Try this one out. Do you notice something different about this one? I hope you do. It doesn't equal 0. So go ahead and subtract 36x on both sides first. And then let's find that biggest number. So 3x is their common number. Remember, please try to pause the video, try it, and all the way through, replay the video when you're ready to check it. Did you find 2 numbers that will give you 12? I know 3 times 4 works, but try something else because we need something that will subtract. Remember, this is a negative. Subtract each other to give you 4. 2 times 6. I hope you found it. Did you put the negative with the 6? I need that negative 4 in the middle. So this should have 1, 2, and 3 solutions. All right, how did you do? Check them out, please. Remember, x equals 0 is a perfectly good answer, so don't forget about those single x's in the front. Okay. All right, now it says you try. There are 4 problems. I know it's a lot, but please pause the video, try all 4 problems, and then continue the video when you're ready to just check your answers. All right, hopefully you had a chance to try it. Be honest with yourself and check your answers. These are just the answers. and you could work back to check your work. Did you try C and D as well? Now this D, look, it is cubic, so I'm looking for 3 answers, but sometimes, remember, we have a double root, so you only see 2, but there could possibly be 3 of them. Okay? All right, hang in there. I know it's a long one, but we got to finish a few more examples. This one right here, when we factor, I see 1, 2, 3, 4 things. And when you see 4 things, you want to factor by grouping. So remember lesson 4.4, to factor by grouping, you can draw a box. All right, so once you do that on the side for me, draw a box, a 2 by 2 box, and throw all of these inside. So when you factor out, put all 4 terms inside the box, and you want to find common things going out. Okay, so if you need a review of this, please rewatch video 4.4a. It will review with you how to factor by grouping. All right, I hope you got these factors. Okay, it's okay if you wrote x minus 2 first and then x squared minus 9. Now I see x squared here and 9 is so perfect. Remember 3 times 3? So yes, you can factor that one more time. So this one has 3 solutions. You're still going to set each part equal to 0, and then you're going to solve them separately. All right, you want to undo every single one, and this one you have 3 answers. Sometimes it's okay if you want to write them together. I know big ideas, you do have to put your roots and solutions all separately. Sometimes you can write as plus and minus, so positive and negative 3, and a positive 2. Okay. All right, so pause, really retry the next few. I'm going to go a lot faster, so pause the video when you need to, but there's another box here. So go ahead and throw all 4, draw yourself a box, put all 4 terms inside the box, and factor the greatest common out. All right, this is what I got. Okay, now I see x squared here, but 3 is not a perfect square like 9. 9 was 3 times 3. There's no way I can find a perfect number times itself to equal 3. So I cannot break this into 2 separate factors like example A. So from here, I'm going to split it into 2 parts. Now here you can still solve. I'm going to undo this minus. So I'm going to add 3 to both sides first. And then, do you remember how to undo a squared? This goes all the way back to part 1, Algebra 2, part 1. So it's last semester. You want to square root both sides. But see that squared? There are supposed to be 2 answers there. So when you square root both sides, can you remember to put a positive and a negative? So that's an ugly square root sign. But so there's going to be a positive square root of 3 and a negative square root of 3. And that last term just minus 4. So there are 3 solutions to this problem. All right, let's try a few more. We're almost done, okay? I know this one's a long one. 4, 5b is going to be a short one, okay? All right, so these 2 have 4 terms again. Please give it a try on your own. Put it in a box and see how far you get. And then come back to check your answers. For problem C, I have positive and a negative square root of 6 and a positive 10. And for letter D. Now, Lows on letter D, I could factor this again. This could be x minus 2, x plus 2, or if you follow with me, hold on, I can do plus 4 on both sides right now, but I have to remember this one's x squared. So when I square root, I can square root 4. The square root of 4 is 2. But don't forget there are 2 answers, just like plus and minus square root of 6. This one's plus and minus 2. So square root of 4 is 2. So if you can square it nice, please go ahead and write it. When you can't, Big Ideas does like exact answers, so you'll have to type in the square root of 6 if you cannot square root it perfectly. Always try it with the calculator if you're not sure. All right, last one to finish this is minus 6. All right, we went through a lot of examples, so we're pretty much done. If you'd like to try this, here are the solutions so that you can self-check if you would like. And that would be our last example. Give the homework a try. I know it's a lot of factoring, so hang in there. Show you work on a piece of paper. It does help on factoring, okay? So good luck on